Let's move on towards Clayden lecture 13. Okay, so the compounds need not lack color. Okay, so what the author is saying is that it is not necessary that all the compounds will be colorless. It is not necessary. Okay, indeed, we can soon dream up a rainbow of organic compounds covering the whole spectrum, not to mention black and brown. Now, what does it want to say? It is saying that we can soon dream of a rainbow. Rainbow, what does it mean by rainbow? Rainbow has color Vibgyor. Okay, rainbow has the colors Vibgyor. Okay, violet, and what are these rainbow colors? These are 7 colors of a rainbow. These are 7 colors of a rainbow. Okay, now what are those colors? V for violet. Okay, V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, R for red. Okay, so this is Vibgyor. So the compounds can have any of these colors. Okay, and in addition to these 7 colors, the compound can have any of these colors. Okay, it can be violet, it can be indigo, it can be blue, it can be green, it can be yellow, it can be orange, it can be red. Okay, and intermediate color also. Okay, among these intermediate colors will also be present, so it can be of that intermediate color as well. For example, some compound may be there which is reddish orange. Okay, some compound might be there which is reddish orange. Some compound might be there which is greenish blue. Okay, so these things are possible, and along with these Vibgyor colors, black and brown colors are also there. Along with these Vibgyor colors, black and brown color are also included. Okay, and finally one more color is there which is colorless. Okay, colorless. Colorless. So it is. So these are the possible colors of a compound, but the author is saying that compound might be colorless or might not be colorless. Compounds might be colorless or might not be colorless. So we can soon dream of a rainbow of organic compounds. That is, we can soon dream that some compound will lie here, some compound will lie in between, some compound will lie here, some compound will lie here. Okay, so in this spectrum, the color of the compound in this spectrum can lie anywhere. Okay, in this spectrum, the color of the compound can lie anywhere. That is what the author wants to say. Okay, in this table we have avoided dyestuffs. So the table which I am going to discuss next, this is the table which I am going to discuss next. Okay, so in this particular table the author has avoided dyestuffs. Okay, dyestuffs he has avoided, that is dyes, he has avoided dyes. Okay, because dyes obviously have color, it is very obvious that dye will have color, so he has avoided dyes and he has chosen normal organic compounds instead of dyes. He has chosen normal organic compounds. Okay, and have chosen compounds as varied in structure as possible. So the diversity in compounds, whatever diversity we have in compounds, the author has chosen that. Okay, so he has chosen compounds as varied in structure as possible. Okay, he has chosen such compounds which are as varied in structure as possible. So let us have a look. Okay, have a look at this Vibgyor. Okay, the Vibgyor is Vibgyor, Vibgyor. So over here it is red, over here it is violet. Okay, and these are the intermediate colors. Okay, so this is the complete spectrum from violet to red. This is the complete spectrum from violet to red. Okay, now color red. So over here at the color red, this particular compound lies. It has a color red. This particular compound, obviously it is talking about 100% pure state. Okay, it is talking about 100% purity, at 100% purity. So at 100% purity, this particular compound has the red color, and the IUPAC name of the compound is given 3-methoxybenzocycloheptatriene 2-one. 3-methoxybenzocycloheptatriene 2-one. This is the IUPAC name of the compound. Okay, and what is its description? Its description is the dark red hexagonal plates. So what does it mean by having dark red hexagonal plates? So when the compound is 100% pure, it is present in the form of dark red hexagonal plates. Okay, so it is present in the form of hexagonal plates like this. Okay, it is not talking about the crystal structure. Please keep this thing in mind. When he is describing the structure over here, he is not talking about the lattice structure. Okay, we are not talking about lattice structure. We are not talking about lattice structure. We are not talking about lattice structure. We are not talking about that. We are talking about the overall structure. That is, suppose we allow the crystal to develop. Suppose this compound has a crystalline nature. This compound suppose has a crystalline nature, and we allow the crystals to settle and develop. Okay, So when the crystal will be developed, it will be in the form of hexagonal plates, thin hexagonal plates. This crystal structure will be visible to the naked eye. Okay, it is not talking about face centered cubic, body centered cubic, rhombohedral. All those things he is not talking about. He is talking about the appearance to the naked eye. He is talking about appearance to the naked eye. So dark red hexagonal plate. So this is dark red color hexagonal plate. Okay. So this particular compound has a red color and it appears in the form of dark red hexagonal plates when 100% pure. Okay. Now this particular compound dichlorodicyanoquinone DDQ, dichlorodicyanoquinone DDQ. This is the structure, and this has orange color which lies over here. Okay, in the spectrum it lies over here. Okay, now description of this particular compound. It is in the form of amber needles. Okay, amber means amber is referring to color. Amber is referring to this particular color. This particular color is being referred to as amber. Okay, and needles. What does it mean by needles? We have all seen sieving needles. Okay, we all have seen sieving needles. Okay, what does it mean by sieving needles? Sieving needles in Hindi we can say silai ki sui. Silai ki sui. Silai ki sui. In Hindi we can call it silai ki sui. Okay, so for sieving the cloths, the needle used for sieving the cloths, that is the shape, that is the shape of this crystalline compound. So it appears in the form of needles. Okay, the crystals develop themselves in the form of needles. Okay, the crystals develop themselves in the form of this kind of needle which I have shown to you in the figure. Okay, so this is the thing. Now comes yellow colored compound. This is diazomethane. The structure is over here, diazomethane. Okay, and it is toxic yellow explosive gas. It is an explosive gas and it is toxic also, and it is yellow in color. Over here you can see. Okay, so it is explosive gas. It explodes when exposed to the air. It explodes when exposed to the air. Okay, so toxic yellow explosive gas. Now green color. Okay, so this is the compound which has green color. Now what is the name of this particular compound? 9-nitro. So this is not IUPAC name, by the way. Okay, this is not the IUPAC name, because Giulolidine is a common name. So this is not an IUPAC name of this compound. This is common name of this compound. So 9-nitroso Giulolidine. Okay, 9-nitroso Giulolidine. This is the name of this compound, and the description is green prisms with a steel blue luster. So it appears in the form of prisms. Prism, you must have heard about prism. A prism is a something like this. A prism is something of this kind. Okay, so I am not able to draw it properly, but you got the idea. What is a prism? You must be knowing. It is triangular in shape. Okay, it is triangular in shape. So this particular compound forms green prisms. It appears in the form, if we allow this compound, if we allow the crystals of this compound. Okay, if we allow the crystals of this compound to grow, okay, to grow slowly and at 100% purity, then what will happen? Okay, so the compound will appear in the form of green colored prisms, and these green colored prisms have a steel blue luster. So newly made stainless steel has a steel blue luster. Okay, so it is bluish luster is present. Bluish luster is present in steel. Okay, so it has green prisms. This compound has green prisms, and those green prisms have a steel blue luster. Okay, so the way blue luster is there in steel, similarly these green prisms will also have a blue luster. Okay, so this is the compound which we are talking about. Now, what happened? I don't know. Okay, I don't know what is happening. Okay, so I have successfully put it to the upper side. Now we will talk about azulene. Okay, this is the structure of azulene. And it is blue in color. It is deep blue liquid. At room temperature it is a deep blue liquid, and it has a papery smell. Okay, it has a papery smell. Now what does it mean by paper? P-E-P-P-E-R. What does it mean by paper? So paper is a kind of spice. Okay, P-E-P-P-E-R. It is a kind of spice and it is called Kali Mirch in Hindi. In Hindi, it is called as Kali Mirch. Okay, in Hindi, it is called as Kali Mirch. Okay, black pepper. We can also call it black pepper. So the smell of this pepper. Okay, so the azulene smell is very similar to pepper's smell. Okay, so azulene is a deep blue liquid and it has a peppery smell. Its structure has been shown here. Its common name is azulene. Its common name is azulene. What is the IUPAC name? No need to know. No need to know the IUPAC name. Okay, and finally this compound which is purple. So what is this? It is nitrosotrifluoromethane. Okay, nitrosotrifluoromethane. It is purple in color. It is a deep blue gas. It is a deep blue gas, and it condenses to a purple solid. When we condense this gas, it is a deep blue gas. Like this, color is like this. And when we condense it to a solid, it becomes purple in color, like this color. Okay. When we condense it, it becomes a purple solid. And under normal conditions, it is a deep blue gas. Okay, so this is the thing. And in addition to these compounds, in addition to these colors of the spectrum, Vibgyor colors of the spectrum, in addition to these Vibgyor colors of the spectrum, black and brown color are also there. Black color is there and brown color is also there. Black and brown colors are also there, and some compounds might also be colorless. In addition to this, some compounds might also be colorless. Okay, like water is colorless, transparent. Okay, thank you very much.